Hey everyone, this is Steve here. I want to talk to you about some of the ideas that have been floating around and we've been discussing around increasing student retention scores, dropping those DFW scores. And there's been a lot of them: UDL, Makerspace, Cure, flipped classroom, discovery learning, interactive lectures, active learning, the list goes on and on. So some of the questions have been, well, which one do I use? But I want to reorient that question to which one should I use when? Because all of these things are related to each other. They're not isolated, like there's not this and there's this strategy and there's not this strategy and this strategy up here. They're not separate from each other. They're related when it comes to how our brain functions through learning. That learning cycle, there's a physical part of learning that goes along with the behavioral part of learning. James Zool has a book, the late great James Zool has a book, The Art of Changing the Brain, which is fantastic if you really want to get into the nitty gritty and all the little details, so that we can't cover in a short form video like this, but it's there if you want it. But Zool was talking about the physiology of the brain. He was a biology professor at Case Western, and he was talking about how we learn and there's sensory input that comes into the brain. So we want to look at the sensory input. And then that sensory data comes into our brain, into the temporal lobe, into the back integrative cortex. And then that information tries to connect with things that we already know and recognize patterns. And then when it does, it moves into the front integrative cortex and the frontal lobe. And then when we get into this area, these actually talk to each other a lot, but the front integrative cortex is developing new ideas. And then when we come up with a new idea, then we want to move that into motor skills. And that goes into an output. So we have a cycle here. There's input from the outside into our sensory portion of the brain, which moves to the temporal lobe, to the back integrative cortex. It moves into the front integrative cortex, into the integrative parts where it generates new ideas. It moves into the motor skills. And then when we do something, then that goes out to a physical output, which in itself becomes an input into another idea or another sensory download. So we can kind of superimpose a brain onto here. It's not a great picture, but you'll get the idea. And again, this is an oversimplified view of what's happening in the brain. There's a lot of different stuff that's happening, but it'll give us an idea. And he was inspired. James Zool was inspired by David Kolb. So David Kolb had the experiential learning theory, and what Zool looks at from the physical sense, from there's senses that are putting input into our brain, he looks at that as a concrete experience. And then David Kolb says we go into a reflective observation phase. And then we move from reflection into creating abstract hypotheses. And then when we have a hypothesis, then it has active testing. Right? And this is also a cycle, from concrete experience to reflection to hypothesis generating to testing, and then this comes back to a new concrete experience, because when we actively test an idea, that's creating an experience in and of itself. Now, this is interesting because it gives us a way to layer things into our teaching strategies. Because if we look at traditional teaching, it doesn't go all the way through the learning cycle. That's why some of the kids struggle with this. So lecture, we're giving input into the brain, and then it's going into the the temporal lobe, it's going into the back integrative cortex, and it's integrating with what we already know. But then when we just give them a multiple choice test, it doesn't really force them to push into the frontal lobe where they generate new ideas. So we're backloading the brain. We're using the sensory part of the brain. We're using the back integrative cortex, but we're underutilizing the front integrative cortex in motor skills. So it doesn't really capture the full learning cycle. And that's one of the things that we're trying to correct. Now, on the total opposite end is discovery learning, where students just start playing with stuff, trial and error on things, and that's loaded on the back end of the learning cycle, or the front end of the brain, where you're dealing with generating new ideas and you're dealing with motor skills, and we're emphasizing this side, but we're de-emphasizing the back side where there's input and the pattern recognition and integrating with things that we already know. So it's also underutilizing the learning cycle for a completely different reason. Lecture multiple choice is looking at overemphasizing the front end of the learning cycle, the back end of the brain. The discovery learning is overemphasizing the back end of the learning cycle, the front side of the brain. But we want to find things and strategies that will run students through the whole learning cycle and balance that out. And there's different ways of doing that. Cures is one. Flipped classrooms, as long as you add interactive ideas, interactive lectures, active learning skills. These are things that force us to go through the full learning cycle, or force the students to go through the full learning cycle. Let's take interactive lecture. So you've got input, you've got students trying to deal with connecting that data into things that they already know, and recognizing patterns and categorizing things and figuring out spatial relationships. But then if we give them an activity where they have to create informed ideas on their own, that's pushing them into the front integrative cortex. And then this goes back and forth, actually. This isn't just a one cycle. The frontal lobe and the temporal lobe are always firing back and forth with each other to create new ideas, because new ideas are based on the old things that we know. So let's take think, pair, share for a second. We're in a lecture. We're giving them ideas. They're trying to recognize patterns and integrate that information. When we have them sit and do a short-term writing to learn, then it forces them to start generating new ideas on their own. And then writing is a motor skill. Speaking and writing are some of the most complex things that our bodies can do. So it forces them into doing a motor skill where that output now creates an input into the senses, because they can see what they're writing, they can correct it or change it or move it around or generate new ideas. And if we do a pair with that, once they've written and they've gone through the learning cycle, and we pair them up to discuss it with somebody else, we've got input they have from both of the students. They have to start recognizing the patterns and integrating it into what they know. The two of them together have to start generating a unified thought. And then the two of them speaking with each other is another motor skill. Again, speaking and writing are complex motor skills, which is an output, which becomes an input into the learning cycle. Again, we come back, we share that into the class as a whole. We run through this again. So think, pair, share will take a student through the learning cycle 3 different times. So that's what we're doing when we're trying to add interactive ideas into, or interactive activities into a class period, which is what the flipped classroom is trying to do. It's trying to push out that focus on the back end of the brain, that overemphasizing on the sensory and back integrative section. We're pushing that input to the home use where they can start generating ideas, but when they get into the class, now we're giving them interactive activities where we can start running through these cycles over and over and over and over again. Because when we're doing new ideas and we're doing motor skills, we're creating new neuronal networks, new pathways in the head. And the more that we run through these patterns, the more solidified those new pathways begin. The brain actually gets bigger when we learn, which is kind of a bizarre concept, but it's true. Other things, Cure, for example, research-based learning, same thing. It's designed to run a student through the learning cycle. They've got to create a plan for what they're going to do for research. When they start collecting data, they're in writing about what they're collecting and analyzing it, they're running through the cycle again. When they present that information to a small group, and they have to integrate that with the small group, they run through the cycle again. When they have to present that to the class, there's a motor skill there, they have to run through that cycle again. Now the bonus for Cure is you're also creating identity of what they are as a scientist, which is a bonus. But it's research-based education is really set up to give them a reason to run through the learning cycle over and over and over again. Now UDL isn't necessarily a learning strategy or learning theory. What UDL is doing is taking away things that are blocking the learning cycle from completing. So it's coming at it from a different angle. One of the big things for UDL is access to information, right? So if you don't have access to information, your learning cycle gets cut at the beginning. If there's nothing coming in for the sensory brain to deal with, it's never going to go through the cycle. So you add options for accessing information, which allows the learning cycle to occur in the first place. If you look at the framework and you start dealing with the different 9-box parts of the UDL framework, let's say interest, for example, which is the upper left. Interest is dealing with the temporal lobe, right? If information that comes into our brain doesn't connect with information that we already know, it sits in working memory, and if we never make a connection to something that's already existing, if it doesn't connect to one of the new, if it doesn't connect to one of the existing neural networks, then that information eventually just falls out of the working memory. So to create interest and relevance, we have to connect the input data into what they already know or what they're interested in and what they want to do. But if that gets blocked here because it doesn't connect to one of the students' interests, then they can't go through the learning cycle because it's blocked. So it's UDL saying, it's like when you're dealing with interest and low interest, there's something that's blocking the students from finding a connection to the information that they already know, so we can give them options to find those connections. So it's all about finding options to get around and take away those obstacles. Self-regulation is another one that's on there. It's on the lower left. And the lower left deals with management skills. So this deals with what's happening in the frontal lobe. So when we get the information, and yeah, there's interest to it, now we're trying to generate new ideas. What do we do with this information? We're trying to manage it, we're trying to figure things out, and if they don't have those self-regulation skills, if they don't have project management skills, if they don't have skills to work through a problem, then that gets blocked here. So sometimes we have to give them and help them develop those self-regulation skills, project management skills, problem-based learning skills, so that they can continue through the learning cycle. So UDL is about finding things that are blocking students going through the cycle and taking it away, as opposed to things like Cure in Makerspace, in flipped learning, in interactive lecture, active learning. Those are adding things in to force people through the cycle. UDL is taking barriers away so that they can continue through the cycle. But it's all here. It's all about going through this learning cycle. Input of sensory data, going through and finding patterns with things that they already know in the back integrative cortex, having that integrate with the front integrative cortex, generating new ideas. So we're moving from things that are in the past, they already know, to the future, to what they want to do, and then that gets moved into the motor control section with an output of something that we do, and then that becomes input for the next round through the cycle, and on and on and on. And if we can get students to continually go through these cycles, then we're setting them up for the future. So that we're setting that up to continually learn, because out in the job space, the projections now are students will be going through 17 different jobs in 5 different industries. So they have to be able to have skills where they can add things to their bucket of skills that they can do in the workplace, so that they can keep reinventing themselves for new roles and new jobs. This is the way it goes. This is how it all fits together. So it's not a necessity of should I use UDL or should I use Cure or should I use Flipped Classroom. It's when do I use the Flipped Classroom? When do I use Cure? When do I use interactive lecture? What fits best with what I'm teaching, and what fits best with the students that I'm teaching? I'd love to talk to you about that. We can have some one-on-ones if you want to, and see how all of these different ideas affect your courses in the way that you want to teach them, in the way that your students need to be taught. Anytime you want to, I'll have a list as well on the article below that'll give you some ideas, such as like case studies, problem-based, project-based. All these things are built to run students through this cycle. I'd love to talk to you about it. I'll see you then.